Alright, so the outline of my talk is something like I'll start off with the introduction of NFS Ganesha, and I'll explain about its architecture. I'll talk about about a component of NFS Ganesha, which is a configuration file known as the ganesha.conf. Then I'll move on to NFS Ganesha features, and I'll also compare NFS Ganesha with kernel NFS, and and then I'll talk about, since I'm mostly working with GlusterFS and not Ceph. I do not touch Ceph or RGW at all. I'll talk about Gluster with NFS Ganesha, and then I'll talk about some recent developments or ongoing developments in NFS Ganesha, and then finally I hope to get some feedbacks regarding transport layer security. It's one of the, I think, hot topics in NFS, I guess. So yes, I'll move on. Right. So NFS Ganesha, like most of you here, I guess, know what NFS Ganesha is. So it's basically, it's a user. These are NFS servers in user space. NFS Ganesha basically allows you to hold NFS servers in user space, and it supports your version 3, 4, and your pNFS with and also 9P protocol, 9P for the Plan 9 operating system. The version 3 of NFS was stateless, and from version 4 it was stateful. So I know most of you all probably know what stateless and stateful is, but let me just rephrase what stateless is. So basically, stateless stores no client information, like the FD, the file FD, next byte to read, and etc., stuff like that. But instead it supports the lookup procedure that converts the file name to a file handle, which is a unique identifier. Like it's mostly the inode number for the file. And NFS Ganesha has Fazal, which is called File System Abstraction Layer, and I'll be talking more about Fazal. I'll be talking about Fazal a couple of times in my presentation. So the architecture, right? On the top, we have the network layer, the network 4 channel. It actively listens and captures your network request from the client, which the request then passes through an RPC dispatcher. Here, the RPC dispatcher decodes your request into a RPC, and the RPC dispatcher here uses a subdirectory, subprogram known as the libntIRPC that is used to implement IRPC, and then the request passes through a duplicate request layer. And also NFS Ganesha supports RPC-sec GSS for your user space applications like curb5. Then from there, the request passes to the protocol layer depending upon which protocol you're using, version 3, 4, whichever it is. And from the protocol layer, it passes to the, so I was half asleep when I made this diagram. Just imagine the SAL layer to be on top of the MD cache layer. And the request from the protocol layer, the request passes to the SAL layer. And the SAL layer converts the request to an operation. For example, the write operation to a write request to a write operation, read request to a read operation. And then the MD cache layer basically stores your the metadata cache for the particular request. And then finally, we have the Fazal layer, the file system abstraction layer. Depending on what backend file system are we using, Gluster, Ceph, RGW, whatever it is, it communicates with that, and that goes onto your backend file system. So it makes more sense to have file system Fazal here, since it's easier for NFS Ganesha to also interact with other user space applications like curb5, LDAP. And then we have dbus that basically in a way controls the entire NFS Ganesha process. So you can dynamically send dbus messages to dynamically export and do other things. And we also have logging. Depending on log levels, you can log the results, the progress. Logging basically. Okay, so the configuration file. Although the configuration file has a lot more things, I'm just pointing out I'm touching upon the main parts here, main components. So first we have the NFS core parameter. right? So here, if the block is not defined, it picks up the default values for it. It's basically used for defining your ports to be used for the particular share, for particular share. And then we have the export block, where you can export your file system, the shares that you want to export. It can be multiple. You can export multiple file systems. And then we have it's a generic block, the NFS curb 5. So here you basically, for example, the NFS curb 5 block will communicate with, if I'm using curb 5 for authentication. So this block basically is used to modify functions and options for my curb 5. And then we have the NFS v4, as the name suggests. It's basically used to limit if you want to just go ahead with NFS 4.1 and not 4.2. So yeah, it's mainly for that. And then you have the cache inode layer, the cache inode block that's used to set options for caching. And finally, we have the log block, where you can modify log levels for each for the Fazal layers to store logs. Features. Okay, so NFS, let me just start by talking about Fazal, file system abstraction layer. And it's Fazal is basically, it's like a plugin that's written in NFS Ganesha for your backend file systems. So basically, if you have a file system that you have, and if you have you have a library that supports, you write a library in your file system to integrate it with NFS. You can write a Fazal in NFS Ganesha for it, and then you can just straight up use your file system with NFS Ganesha. So that's where Fazal is handy. And then it supports your dynamic exports using debus mechanism. I spoke about this during the architecture. So you can basically give debus commands to dynamically export and unexport your file systems. You won't have to shut down your entire server and restart and do that. So you can dynamically just give commands and export one of a few shares and not all the shares that you're exporting. Yeah, it's in the user space, so I think which is why it's ideal for huge metadata caching. And also we have I'm not 100% sure about kernel NFS. I think it's if it's not impossible, it's a bit complex to implement high availability. High availability, most of it's basically it's for servers to basically prevent failovers. So if in case I have like multiple servers that are actively serving my clients, so if one server goes down, I have the other servers to support, service for that. So that's what HA is for. And we use pacemaker and corosync, which are actively developed by Red Hat especially. And pacemaker and corosync, if I have to touch up on it, pacemaker I'd say is like in essence, pacemaker is like it decides how your cluster behaves, and corosync is like a message channel that communicates between server and clients. So it supports active configuration. So there's a difference between active and passive and active. So I'd say for the viewers, so most of you here know, I'd say that active is basically where all your servers are up and running and serving your clients, and this is also good for your load balancing depending on the situation. And whereas active passive, you have although there is redundancy, but you have just one server that's serving, and if it goes down, you have the other server that takes its place. Then security and auth mechanism. Yes, it communicates well with other user level applications like curb5 LDAP. So you have auth mechanism similar to kernel NFS. I think it's way much easier. And it's user space, so yes, it's easier to work with, easy to debug. And of course, we are like a small team, so we have a faster development cycle. And faster development cycle, it's not chaotic. And okay, I think chaotic is not the right word here, but yeah, we have a faster development cycle. Integration with GlusterFS. So yeah, firstly, GlusterFS has something called as the GF API, the libgf API, to communicate with the NFS Ganesha. And NFS Ganesha uses, it's basically a wrapper over the Gluster protocol, which interfaces with Fazal Gluster that's written in the NFS Ganesha. So NFS Ganesha uses GF API to communicate directly with the GlusterFS and not go via the traditional Gluster fuse layer. So performance is better in that way, in that sense. And we have the HA implementation for NFS Ganesha, where you use, as I spoke, use pacemaker and corosync for active-active configuration. Here, you need, I think, at least 4 servers to carry out HA implementation. And it fails over seamlessly, and if, let's say, a server dies, most of the clients don't even realize it dies, and the administrator can go and bring up that server without any problem. So NFS Ganesha versus kernel NFS. Firstly, I'd like to mention performance-wise, of course, it's kernel NFS that provides better performance, but NFS Ganesha is quite good. It's not that bad. It has good performance. It gives you good performance. Other than that, it's easier to debug with. We all know how daunting it can be to debug kernel NFS or kernel applications, and it's easier to scale out as compared to kernel NFS. So scale out as in there's a difference between scale out and scale up. So let me just touch up on that, since most of you, I think, but I'll just say that. So scale up is where basically you have a box, you have a machine, and you add in more CPU power, you add in more RAMs, you add in more memory, and you add in more stuff to scale up the box, and then there is only as much as you can put in, and eventually you run out of space to do it, and you've scaled up as much as you can. But whereas in scale out, you can add in more boxes, and then of course you can scale up those boxes. So it's much easier to scale out with NFS Ganesha as compared to kernel NFS. And it's easy to access. Since it's in the user space, NFS Ganesha is in the user space, so it's easier for NFS Ganesha to communicate with other user space applications. It's not as complex as kernel NFS, although it's a bit complex, but it's not as complex. And yes, we are a much smaller community, so we know how. So for development, how daunting it can be to get your patches merged for any kernel projects. But here in NFS Ganesha, it's not that bad, and it's much faster. So some recent / ongoing developments. Labeled NFS. So the labeled NFS, right? So basically, labeled NFS, in short, allows you to set security SE Linux context to restrict processes from interacting with each other. So for basically, if a client requests a file access from a server, and server sends a request back access to the client, I mean, these two processes for the same file are actually different, so you don't want them to mix up, and you can you have better security that way. So it was one of this feature I personally worked on this feature, and it's been merged upstream. Then we have delegation. So this for delegation, I'd say it's more or less, as far as I understand, so it's for better performance, where the client doesn't have to speak to a server, where the client doesn't have to speak to a server, which then speaks with NFS Ganesha, and then to locate a file that, and then NFS Ganesha actually has to find another server where the file is actually located. So delegation allows the server to basically delegate file data to the client so that it can directly access the file. And then we have the sticky grace period. So for grace period, I'd like to touch upon what grace period here is. So when an NFS Ganesha server is up and running, for a while, it takes some time to cool to start a problem. So basically, in the starting, few of the file operations are not permitted, so that the servers can so the clients that were communicating with the server earlier can have the logs for if there were any previous file operations going on. So here in with sticky grace period, the thing is, for in-flight operations, like for some file operations require the server to be in a grace period and some don't. So for so here with this improvement, you have it overcomes the problem of in-flight file operations. So basically, you don't flip your sticky the grace period. So it basically suited for a cluster NFS Ganesha cluster, right? And then we have the async IO. I think most of you know what async IO is. Yeah. Okay. So finally, I have transport layer security. There is no, as such right now, there's no proof of concept for it, and this is a project that my team has been asking me to get a reaction from community, from NFS enthusiasts like you. So I urge all of you to participate, like chatter about transport layer security, since we have curve 5, but it's a little bit complex, and you might as well have transport TLS, and so I'm hoping to get some reaction, although there is nothing right now for it. So, but depending on the reaction we get from the community and about the I don't know, any suggestions that the community may have, we may start working on TLS. So please feel free to get in touch with me after the talk. If you have any suggestions, you may just raise your hand and say anything you like about it. Yeah, that's all. And questions. Yeah.
Should I go with
My.
Yeah, then it's recorded. So you just have to speak up as well, because the mic's just for the recording.
Okay. Thanks, Arjun, for the talk. I have one question regarding this async IO you have mentioned in the cluster.
Sorry. Regarding.
Okay. Okay. So I have briefly worked in NFS Ganesha layer to develop our own proprietary file system. So I have used async IO and 2.5 version of NFS Ganesha. So I wanted to know, like, what is the state of, sorry, I use sync IO. I wanted to know what is the stage of async IO. Are you guys in Gluster have already implemented upsell for async, or still you guys are using sync and it's still in the development phase, not in the production ready? In case of Gluster, I know that APIs are available from NFS Ganesha side, but how robust they have been integrated with the GlusterFS. Just want to know your view and how team is reacting on it.
So right, thank you for the question. Okay. Question, I'll repeat the question. The question basically was, how robust is async IO with GlusterFS? In short, right? So, okay, as far as I know, that it's the development is still going on, but it is better with Gluster. It's there, and it works well. I mean, I'm saying this because you also have an option for going just with the synchronous IO and not the async. So I think the async is in a pretty good state right now, but I'm not sure where it is exactly right now. So yeah, I mean, I'd be happy to shoot you a mail with after I research about it a little bit more, and then definitely follow up with you. Yes, please.
Okay, just speak up. So we use ZFS with NFS Ganesha on top, and I'm curious what you mentioned about the caching, the empty cache layer. It sounds like that's a major contribution to a potential performance benefit, in particular with considering ZFS isn't terribly performant with the metadata, in particular in small files.
Okay.
Is that correct? Should I focus on that and give it a lot of the cache area?
Okay, so the question is for Ceph, since metadata is, I think, an issue with Ceph, and NFS Ganesha has an MD cache layer, so should he just rely on NFS Ganesha's MD cache layer and shoot more more metadata for it? For that, so firstly, I'd say I'm not familiar with Ceph, like the problems and the limitations with Ceph, which Ceph has, although I've just heard about it. I think metadata is a big of an issue in Ceph. Since I'm not that aware, what I'd say is, yes, so this is what my understanding is. Please jump in if you have something to add on, Niels. Since it's a user space, it has the ability to store a lot of metadata. So I think if that's what you're looking for, to store a lot of metadata, maybe. So yeah, I think that's.
Can I add here something? So I also faced some problem with MD cache layer. There was some bug and there is a lot of improvement in MD cache. So in my case, we have developed our own caching layer for metadata.
Oh.
Yeah, yes. And MD cache, you cannot get rid of MD cache. You have to go pass by MD cache. So just think about as object in layer and develop your own. That's what we have done. And it was quite good. So you cannot get rid of
The answer is it depends, right? The MD cache layer is great, but anytime you're stacking caches like this, because libcfs has its own kind of caches a lot of this data as well. Well, it has to for the caps, right? So it has to do that for caps. So anytime you're doing that, you always have cache coherency issues that you have to work through. So some things time out, some don't. The issue though is that you're double caching too, so you're going to consume a lot more memory if you use the MD cache layer that way. The one, most of these are in-memory operations, so and all in the same process. So you're probably not going to get a whole lot of benefit from doing that. The one thing that is the problem with libcfs is that it's all under a giant mutex, and so you can get contention on that mutex. If you're doing a lot of threading. If you want me, I can talk to you about it in a lot more detail later if you want. But yeah, the question, depending on what you're doing, it may help you, but it may harm you too.
Yes.
Right. So thank you, Jeff.
Just ask your question.
Oh, okay. Please.
Sorry, that was the other part too.
Yes, please.
What, can we get one more? Sorry. One more second.
The other part too is that we don't have any upcalls from libcfs to call to Ganesha to invalidate stuff. So if we get cap revoked, then and you lose and the metadata changes, it may be difficult for Ganesha to know this. So.
So if you have one Ganesha and it's the only thing that talks to ZFS, it's fine. But if you have two Ganeshas running independently, or some ZFS and some Ganesha, then that's bad.
Thanks, guys.
Yes.
Any plans for different HA options? So, for example, we run Ganesha in a container,
Okay.
and like the corosync pacemaker, it doesn't really is great for that. So, perhaps something like using Raft or secret transaction.
Right. So the question is if there is any other option for HA as related to pacemaker and corosync, if that's what I hear correctly. So since I've only used pacemaker and corosync, I'm not sure what the other the other application that you mentioned, Raft, I think. I'm not sure about it. But as far as I know, it's only pacemaker and corosync that we use for HA, in GlusterFS especially. So, yeah.
I have used Epson layer, Epson layer, and we have used Zookeeper for our HA. It doesn't enforce you. Oh, sorry. So NFS Ganesha, the good part is that he does not enforce you to use something. So we used Zookeeper for HA, and we have written our own duplicate request cache DDRC for our own metadata DRC purpose. So it is possible, yeah. It's quite it's quite pluggable architecture. That is the best part of NFS Ganesha, I would say.
Is that fast
Yes,
enough?
yes, indeed, yes.
Okay, so you want to add something?
Yeah. There's actually some native clustering inside there too. If you're using Ceph, so Ceph, I built a way to do active HA with it using just Ceph on top. So using Rados basically, it kind of maintains a shared state database between the Ganesha servers. I can point you at a couple talks I've given on it if you want to see them. So.
So many friends.
Any more questions?
Yes.
Just ask your
Just
question
ask.
and we'll repeat it.
Do you have clients in user space as well?
Sorry,
So like Fuse,
do you have?
client in user space. Just right.
User
Fuse,
space client.
what does it mean user space?
I'm sorry, I'm not hearing that.
Client access. So do you have user space clients? So for example,
User space clients.
do you have a Fuse client?
Yeah.
A Fuse NFS client.
Fuse NFS clients. Okay. What I know is I know what Gluster has a Fuse, but I'm not sure if NFS Ganesha has a Fuse.
No, exactly.
And
So
yeah, NFS just
so there are NFS client utilities that you can use NFS,
utils.
the NFS protocol from a client side. There are libraries for that, but they're not part of the NFS Ganesha project. So NFS Ganesha is really the NFS server. The NFS client is either the Linux client that you have in the Linux kernel or NFS utilities in user space. So, yeah. They exist, but yeah.
Thank you, everyone. Oh, any more questions?
Okay. I guess if there's no more questions, then okay. So we'll do one more. Sorry.
Thank you for your talk. So the question about the clients, so for example, if there are no, for example, system, no single IP is used and no pacemaker or other things, but you have two active servers and you use something like AutoFS on a client side, so you do multiple connections, and how that can work with Ganesha to achieve HA for that kind of case.
I'm sorry, I didn't get the. Okay, we have like two servers, active.
Active. So you have multiple active nodes, for example, 5, 10.
Okay.
Yeah, and you need to reconnect to every time to different AP. So you don't have pacemaker, you don't check the availability of nodes, but you just once it failed, you need to reconnect, and you're using, for example, AutoFS for like a wrapper for client to do multiple connections. And yeah.
Okay, I don't think I fully understand your question, but I think I think what you're asking is about the IP connection for IP addresses that the client uses.
You have a host name and multiple IPs, so they're just
so
withdrawn from DNS.
we in the NFS Ganesha server has like virtual IPs, VIPs for every multiple IPs for every node in the servers. So yeah, I mean that points you to a different, like if for failovers, that's what points to a different server. So